Hello everyone, how to solve this problem for the values of a if we have a plus 3 whole cubed plus a plus 5 whole cubed is equals to 8, and we solve this problem for the real values of a. So here we need to find all the real roots of this equation and we move towards the solution of this problem. So here first we rewrite this equation as this is the cubic equation. We rewrite this equation as this is a plus 3, we write it as a plus 4 minus 1 whole cubed plus this is a plus 5, we write it as a plus 4 plus 1, we write this 5 as 4 plus 1 and we write this 3 as 4 minus 1 whole cubed is equals to 8. And further in the next step we just take here this a plus 4 be the common term, so we take it equals to x and it will becomes x is equals to a plus 4. And when we substitute this value into the above equation, it will be written as x minus 1 whole cubed plus this is x plus 1 whole cubed is equals to 8. So our given cubic equation will be converted into this form. And here we use the nice cubic formula, you know about that. If we have a cubed plus b cubed is equals to a plus b times of a square minus ab plus b square. And you see here the base of this term is our a and the base of this term is our b. So according to the below formula, we write our above equation as in this form. So first we have this is a plus b, the value of a is x minus 1 plus the value of b is x plus 1 into this is a square, the value of a is x minus 1 whole square minus the value of a is x minus 1 and b is x plus 1 plus b square, so the value of b is x plus 1 whole square, and this whole equation is equals to 8. And here we need more simplifications and we get this is plus 1 and this is minus 1 are cancelled out by each other, and we get here x plus x is equals to 2 times of x. And here we use the nice algebraic formula, you know about that. X minus 1 whole square is equals to x square minus 2 times of x into 1 plus 1 square minus, and here we apply another formula, x minus 1 into x plus 1 is equals to x square minus 1 square, and plus here we again use the formula and it will becomes here x square plus 2 times of x into 1 plus 1 square, and this whole equation is equals to 8. And here we need more simplifications and it will be written as this is negative 2x and 1 are cancelled out by this is the positive 2x and 1, and here we need more simplifications and we get this is 2 times of x. And here when we apply this negative sign on both of these two values, it will becomes this is x square plus x square becomes 2 times of x square, this 1 square becomes 1 and this 1 square is also becomes 1, so this 1 plus 1 becomes here 2, and we apply this negative sign on each of these two values and it will becomes minus times of x square plus this 1 square becomes 1, and this whole equation is equals to 8. So further in the next step we need more simplifications, and here we have this is 2 times of x into this 2x square minus x square becomes here x square, and this is 2 plus 1 becomes here 3, and we move this 8 from right hand side to the left hand side, this is positive 8 becomes negative 8, and this whole equation is equals to 0. And here we multiply 2x separately on both of these values and it will becomes 2x cubed plus 2 times 3 becomes 6x, this is minus 8, and this whole equation is equals to 0. And now you see here each of these terms involve 2, so that we divide both of the sides by each of these terms by 2. Okay, so we divide each of these terms by 2 on both of the sides. These two and these two are cancelled out by each other, and we get here x cubed plus these are also cancelled by each other. 2 times 3 becomes 6. We get 3x. 2 times 4 becomes 8 is equals to 0 over 2 equals to 0. So after a little bit simplification, we get x and we get our given equation into this cubic form, and here we just break this equation and we easily make the factors of this equation. So we solve this cubic equation by factorization technique, and it will be written as this is x cubed, and we write this 3x as minus x plus 4x. Minus 1 plus 4 becomes plus 3, and this is minus 4 is equals to 0. And in the next step, you see here on first two terms we will take common x and we get the remaining values are. So here we get x square minus 1 and plus here we need to take common 4 and we get the remaining values are x minus 1, and this whole equation is equals to 0. And further in the next step, here we need to use the nice formula here. So x square minus 1 is written as x minus 1 times of x plus 1, and this is plus 4 times of x minus 1, and this whole equation is equals to 0. And now here in the next step, you see here both of these two terms involve x minus 1, so that we take common x minus 1 here and we get so here we get this is x times of x plus 1, and this x minus 1 is take common and we get here plus 4, and this whole equation is equals to 0. And in the next step, here we divide this equation into the two cases. The first case is we write x minus 1 is equals to 0, and the second case is we write this is this will becomes x square plus x plus 4 is equals to 0. So here we need to focus on both of these two cases and we easily get the values of real values of x. So from here we get the value of x is equals to 1, and now here we move backward and we put the value of x here. In the start of the problem we will take here our x is equals to a plus 4 is equals to 1, and when we move this plus 4 to the right hand side we will get here a is equals to 1 minus 4, and we get a is equals to minus 3. So this is the real value of a, which is the required value. And now here we need to focus on this case, and here we check that is this quadratic equation has real roots or not. For this we use the quadratic discriminant formula to verify the roots. Okay, so for discriminant formula, first we need to write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 1, and c is equals to 4. And we know about discriminant formula, so it is equals to b square minus 4 times of ac. So if the value of this discriminant is negative, then we say that it has complex roots. So if the value of this d is positive, then we say that it has real roots. So we put these values here and we get 1 square minus 4 times of 1 into 4. So 1 square becomes 1, 4 times 4 becomes 16. So the value of discriminant is equals to minus 15. So this shows that discriminant is less than 0, and this means that it has complex roots. Okay, so this shows that our given quadratic equation has complex roots. So this equation does not gives us the real roots, so that we rejected this case, and we have only one real root of the given equation, and that is a is equals to minus 3. This is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.